Welcome to BSc Main Physics. And this is a question paper, University question paper, 2022 June question. Semester 1, paper 1. Semester 1, paper 1, question paper, BSc Main. The latest question paper, that is 2022 June question. The examination was in August. And the paper is Mechanics and Properties of Matter. The question paper I shall read here. You look here, first semester BSc degree examination June 2022. First degree program under CBCSS Physics, Core Course 1, PY 1141, Basic Mechanics and Properties of Matter for 2020 admission onwards. Maximum marks 80, time 3 words, section A. 80 maximum mark. പാർട്ട് എ പാർട്ടാണ്. എ പാർട്ട് 1 മാർക്ക്, 1 വേർഡ് അല്ലെങ്കിൽ 1 സെൻറ്റൻസിൽ ഉത്തരം പറയേണ്ടതാണ്. ചോയ്സ് ഇല്ല. Answer all 10 questions. Each question carries 1 mark. What are rigid bodies? Question number 1. Question number 2, give the moment of inertia tensor. Number 3, what is the unit and dimension of moment of inertia? Number 4, define Poisson's ratio. Number 5, give you examples of a catenoid surface. Number 6, if a liquid with a solid surface, angle of contact is, you have to say obtuse or acute. Number 7, the equation of continuity for a fluid expresses the conservation of dash. Number 8, what is the instrument used to measure rate of flow of water through a pipe? Number 9, give an example of simple harmonic motion. Number 10, define amplitude. 10 into 1 equal to 10 marks. Section B, answer 8 questions. Each question carries 2 marks. Number 11, differentiate rotational motion and translational motion of a rigid body. Number 12, give the properties of moment of inertia tensor. Number 13, give 2 examples of rigid bodies having equal values of principal moments of inertia. Number 14, state work energy theorem. State work energy theorem. Next question, differentiate stress and strain. Number 16, what is torsional oscillation? Give equation for a time period of torsional oscillation. Number 17, define surface tension. Number 18, give a short note on molecular theory of surface tension. Number 19, what is angle of contact? Number 20, surface tension of a soap solution is 0.03 Newton per meter. Newton should be in capital letter. Newton per meter. How much work is done to produce the soap bubble of radius 0.05 meter? Next question, number 21. Oil spreads over surface of water, whereas water does not spread over surface of oil, S-plane. Number 22, What happens to angle of contact of if temperature is increased? Number 23, spline, Stokes law of a viscous liquid. Number 24, differentiate streamline flow and turbulent flow. Number 25, what is simple harmonic motion? Number 28, distinguish between mechanical and electrical equations of motion. Next is section C. Answer any 6 questions, not exceeding a paragraph. Each question carries 4 marks. It is a problem type question, and some theory is also asked. Theory part is also included. Number 27, show that the motion of a rotating rigid body obeys the rotational analog of Newton's cycle of motion. Number 28, show that the torque on a rigid body about a given axis is equal to the product of moment of inertia of the body and angular momentum about the axis, and that is angular momentum about the axis is equal to the product of moment of inertia and the angular velocity about the axis. Number 20, obtain the expression for energy of a rotating rigid body. Number 21, consider a drop of radius 1.00 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meters per second. A. What is the work done by the gravitational force? And what is the work done by the unarested force? Next number, with the suitable examples, prove the conservation of energy of particle. Number 32, obtain the expression for depression of a lowered end of a cantilever with the weight of cantilever not neglected. Number 33, a uniform beam of length L is supported symmetrically on two knife edges in same horizontal plane and loaded with W in the middle. Deduce the equation for depression of the beam. Number 34, two salt cylinders of salt metal having length L and 2L and radii R and 2R are joined coaxially under a couple applied between the free ends. The shorter cylinder shows twist of 30-degree. Calculate the twist of longer cylinder. Number 35, derive the continuity equation. Continuity equation for compressible and incompressible fluid. Number 36, a pendulum is of length 50 centimeter. Find the period when it is suspended in a stationary lift. B, a lift falling at a constant velocity of 5 meters per second. Next problem, find the time period and frequency of a block of mass 1 kilogram attached to a spring and stretches the spring by 7 centimeter. Number 38, deduce the general equation of wave motion. Here it is 6 into 4, 24 marks. Section D, Answer 2 questions. Each question carries 15 marks. Letter 9A, discuss the theorems of moment of inertia. B, calculate the moment of inertia of a circular disk of mass m and radius capital R about 1 its own axis, 2 about the tangential axis parallel to its own axis, 3 about the diameter, and 4 about a tangential axis parallel to its diameter. Number 40, what is elasticity? Obtain the relation connecting three elastic constants. Number 41. 41. Derive the expression for excess pressure on the curved liquid surface like a spherical surface, cylindrical surface, and a cat-node surface. Number 42. With a neat diagram, derive Bernoulli's equation for a steady flow of a fluid. What is its significance? What is the significance of Bernoulli's theorem? Mention its applications. Number 43. Give a note on conservation of laws in mechanics. B. Define 1 work, 2 power, 3 kinetic energy, 4 potential energy. And C. Using work energy theorem, show that the sum of kinetic energy and potential energy is always constant. Number 44. What is a compound pendulum? What are the advantages of compound pendulum over simple pendulum? Discuss the interchangeability of suspension and oscillations of a compound pendulum. It is actually center of suspension and center of oscillation. So here it is 2 into 15 equal to 30 marks. That is solved with your class number 63, the question paper. Thank you very much.